Hey guys, Pankaj here. Welcome back. In today's statistic video, I'm going to talk about confidence interval, which is very important topic because we have already covered Gaussian distribution, normal distribution, right, and some random distribution. Okay, so it is good to know how you can calculate the confidence interval when someone is asking what is your confidence when your this data is lying between this value and that value. Correct. So we'll see how to calculate and how we can determine with the help of Gaussian normal distribution or any kind of distribution. So let me share my desktop. Okay, so let me just talk about the topic which I'm going to cover today. So we'll be talking about confidence interval, which is also known as CI. Okay, so confidence interval for Gaussian normal distribution data. And we will see, we have already seen like Gaussian, how normal distribution looks like, right? So if any random variable or any random value, if we had, it is coming from Gaussian normal distribution, how we can calculate the confidence interval. Okay, and when let's say you have the random data where mu is known and sigma is known, right, and number of samples are known, that is n, how we can calculate confidence interval, we'll see that. And another data where sigma is not known, sigma is not known, how we can calculate confidence interval. All those cases we'll see. So some cases you will be knowing mu, you will be knowing sigma and n. So by knowing all those value, you know Gaussian normal distribution. Any data which is falling between mu plus minus 2 sigma, we can say it is having 95% chances of value which is lying between mu plus minus 2 sigma. Okay, so that is that you can tell only when your value is coming from Gaussian normal distribution. Okay, so we'll see that. So in this case, you should know mu, you should know sigma, and any number of samples we already know, right? But what if sigma is not known? Sigma is not known. So in this case, what to do? We will see something called T distribution. This is also known as T students. Distribution. Okay, so these are the things which I'm going to cover. So let's talk about some examples here. First, I'll draw a Gaussian normal distribution. Here, mu lies at 0, and this is your mu plus minus 1 sigma, and this is your mu plus 2 sigma, correct? This is mu minus 1 sigma, this is mu minus 2 sigma. Okay, your mu is nothing but your sample mean, or you can say population mean if you are taking data from population mean. I'll just talk about sample mean, and sigma your sample standard deviation. Okay, so let me draw another line here. Let's say I have some data which is falling between mu plus minus 2 sigma. Okay, and let's say I have data here x equal to, let's say, height of students. Okay, so 158, 190, some random data I'm picking up, 143, 138, 180, 155. Okay, and the mean of this value is, let's say, coming between, let's say, 170, and standard deviation is coming to, let's say, 5. Okay, so now my question is, what is the probability of getting student height, or the mean of student height is let's say 168 to 172, 168 centimeter to 172 centimeter. What is the probability of getting student height between 168 centimeter to 172, right? So there is something called point estimate. Point estimate. What exactly this tells? Basically, you will be pinpointing like my mean will be exactly 170 centimeter. But this is not good, right? You are just telling pointed value. It may change, or it may be varying a little bit. So what you can do, you can just give between this to this value only mean will be falling. Okay, so if you're telling between, let's say, x to y, it is falling. So what is your confidence? Like my mean will fall between x and y. Okay, that's where it is coming, or it is being told as confidence interval. Confidence interval, which is known as CI. So what is my 95%? Let's say I'm talking about what is my 95% chance of getting mean height between, let's say, x1 and x2. So you can easily calculate this, or by knowing the Gaussian normal distribution. Okay, so we have already seen your Gaussian curve will look like this. If your mu is here, your 95% data will be coming between mu plus 2 sigma and mu minus 2 sigma. Okay, so what is my x and y, x1 and x2 value? So what you can do, let's say you have already given mu 170 and sigma was 5. Okay, so in this case, my 95% of getting probability of mean height between, let's say here it is your 170 plus minus 2 sigma, right? So this will be what? 2 sigma is what? 10. So this will be 180. Okay, and this will be minus 10. This will be 160. So I'm 95% confident that my mean will fall between 160 to 180. So that is what is your confidence interval. Okay, so falling x mean between 160 to 180 is equal to 95%. Okay, or the probability of, I'll say probability of getting x mean, let me just write here, probability of getting x mean where your 160 and 180 mean is equal to 95%. Okay, why it is telling? Because we know by heart, right? Your Gaussian normal distribution look like this, where mu equal to 0 and sigma equal to 1. Okay, but let's say here in this case, in our case, mu equal to, or mean is nothing but 170. Okay, since it is coming from Gaussian normal distribution family, so we know mu plus minus sigma will capture 95% data. Oh, sorry, 95% probability of getting mu between mu plus minus 2 sigma. Okay, and let's say someone is asking 99%, what is my what is the probability, or maybe probability of getting 99%, what will be my interval? Okay, so we know that will be mu plus minus 3 sigma to get 99.7% probability. So you just put the value and get the value, get the interval, and that is what is your confidence interval. Okay, so that's about this data. Now what is next? So in this case, we know that our mu is known and sigma is also known, correct? What if sigma is not known? So how you can handle that? If sigma is not known, so we have something called t distribution. Okay, and that t distribution is nothing but let me just show with the help of wiki page. So t distribution tell that we have something called degree of freedom. Okay, so your degree of freedom look like this. So these are the value where t, where n is dependent, or maybe here we are talking about rho, right? This is your degree of freedom. As degree of freedom is going high, that is 1 to 5, you see here it is very much approaching towards normal distribution. So this black curve is nothing but, you can assume that this is Gaussian normal distribution. Okay, so as your degree of freedom is increasing, it is almost touching the Gaussian normal distribution. And once you have the Gaussian normal distribution, you know that how you can calculate the value of or basically confidence interval. Okay, so in this case, what they suggest, basically student T, what they are suggesting, if you know the degree of freedom, that is nothing but n, you can calculate by using t n minus 1. Okay, so this is the formula for t student distribution. Okay, so if you see here, there is one table called t distribution table. where you should know the degree of freedom, and based on that you can calculate what is your confidence interval. Okay, percentage wise. Let me just show here. Yeah. So higher the confidence interval, higher your bell curve, following the bell curve or normal distribution. Okay, so you can see here this number, the first column is nothing but the degree of freedom, and here is your confidence interval. Okay, probability from, let's say, 50 to 99. So whichever probability you want, and whichever confidence, whichever degree of freedom you want, or that, based on that you just draw a table here. So let's say 4, and I want 90% probability, right? It is coming here. So this will be your degree of freedom. Sorry. Just a minute. Yeah. So what I'm doing, let's say you have a degree of freedom as 3, and you want 80% probability, correct? It is not working. Something went wrong with pen. Okay. Yeah, so idea of this t distribution is when sigma, or maybe this standard deviation is not known, standard deviation is not known, then we go with t distribution. Okay, so formula of calculating this will be t multiply n minus 1. N stands for your degree of freedom. Okay, so which you can calculate from this particular table. So this is your, let's say you want degree of freedom is 3, and you want 95% probability, right? So where it is coming, this is okay. So this will be your value, 3.162. Okay, and similarly for, since we are talking about two-sided, right? This is symmetric distribution for Gaussian normal distribution. So one side, if you want, that will be 97.5% probability, and if you want two-sided, that will be 95% probability. Okay, so that's about this. Okay, so next what we want to talk about, let's say you have some X sample, random sample, some values are there up to Xn. Okay. So in this particular distribution, right, we know that central limit theorem, right? So from central limit theorem, if we know the mean of X, right? So let's say this sample, or let's say this is population, right? So we take so many samples, sample from population. Okay, and central limit theorem says that if you keep taking sample, where let's say sample size is equal to, say, 30, if you take so many samples, S1, S2, S3, and so on, Sn, so many samples, and take the mean of those samples, then as per central limit theorem, this mean of sample will be very much close to the population mean. This mean is nothing but population mean. Okay, so as per central limit theorem, if your data, let's say some data X is having normal distribution, your sample will be sample mean will be very much close to the population mean, and your standard deviation will be population standard deviation divided by root of n. This number is this number is basically number of samples. Okay, and this is nothing but population mean. So when you have this kind of data, right? So as per central limit theorem, we got the formula of this. So let me just color code. Central limit theorem this says this. So how to find the confidence interval for these kind of data where we know central limit theorem? Okay, so what you can do basically, let's say I want from sample means or from sample data which is taken from population, how we can say that 95% probability, what is the 95% chance of getting mean between mu plus minus 2 sigma? This we have seen in the Gaussian normal distribution. Okay, and in this case, when you apply on the sample, this sigma we know, right? What is this? This is nothing but sigma of population or standard deviation of population divided by number of samples. Okay, so your 95% 95% probability for getting mean between mu plus minus 2 sigmas. Instead of instead of sigma, what we can put? Sigma upon root n plus minus. Okay, this will be your confidence interval in case you are you want to have probability of 95%. Okay, so I can, let's say I know the value of mu, let's say coming at 68. I know sigma is coming, let's say 5. Okay, so from as per central limit theorem, you just put the value. So mean, let's say you want to have the value between this and this. Okay, this is x and this is x dash double dash. Okay, so I want to calculate the 95 percentile from this particular sample mean. So as per central limit theorem, we can put the value. So mu is nothing but 168 plus 2 into 5 divided by root of 5. This will be your positive side, and 168 minus 2 into 5 divided by root 5. This will be your negative side. So as a whole, if you take, that will be your confidence interval from the sample data, which is following the central limit theorem. Okay, so that's what I wanted to show about this. So we saw from Gaussian normal distribution, we saw as per any distribution which is following central limit theorem, we can calculate the interval of 95% or whatever percentile you want, whatever probability you want based on this formula, mu plus minus 2 sigma divided by root n. Okay, and we saw another table called t distribution, right? From t, number of degree of freedom n minus 1. That also you can find in case this will be used only in case sigma is unknown. Remember that. When to use t distribution only when sigma is unknown. If sigma is known, then you have two choices, right? Either you go with CLT, that is central limit theorem, or go with the Gaussian normal distribution from mu plus minus 2 sigma, 1 sigma, or whatever confidence you want. Okay, guys. Yeah, so that's all about confidence interval. I hope you liked it, and please remember these cases where exactly we have to use t statistics, where we have to use central limit theorem. Only thing is you have to know the value between value of mu, that is mean of population, or standard deviation of population. If it is not known, then we have sample mu and sample sigma, correct? And if sigma is not known, then t statistics, t multiply n minus 1. N stands for degree of freedom. Okay, so as you go with higher degree of freedom, your data will be very much normal distribution, or it will start following the Gaussian distribution. Okay, so that's all for this video. Thank you so much. Bye-bye.